In this video, we're going to look at Learning Objective A and look at how to compute values when you use the compound interest formula. Now this formula right here you have seen before in past math classes is called the compound interest formula. And let me show you what all the values stand for. So what we have here is the p-value here is what we call principal, or how much we're going to start with. The A is our ending amount. The 1 is just standard in there. It's plus because it's going to be growing versus negative would be decay. The R here is the annual rate, or it's an interest rate. The T here is the number of years. And then the N value is for how many times a year are they going to compound. If they compound it once a year, N is just 1, and that's the more basic formula. But what if they compound it 12 times a year, every month? Then what we have to do is take this annual rate and we have to divide it into 12 so it becomes a monthly rate. And for the year, if it's just for 1 year, they're not going to just compute interest once. If they do it every month, they're going to do it 12 times. So you have to come here and times it by 12. Now let's go to the next slide and analyze some scenarios. If we invest for 1 year at 100% interest, let's look at how much that we're going to have. So here is again the compound interest formula. Let's, for this, all of these scenarios, put $1 in the bank. Again, we're going to do 100% interest, and we'll do it for 1 year. What will change is how often they compound the interest. Now I want us to visualize it like, imagine someone's at the bank and they hit the button and say compute the interest. So this first equation would be our ending amount is our starting amount of $1. 1 plus the rate is 100%. Now n is just 1, and then we're going to times it by, we're going to compound it once a year for 1 year. When you do this, you're going to get that you're going to have $2 in the bank. Now, how's it going to change if the person at the bank doesn't hit the interest button once a year, but twice a year, so every 6 months? Well, the formula is just going to be A equals $1, 1 plus the 100%, but that 100% is for a year, so I have to cut that in half, which it becomes 50%. We're going to hit the button twice a year for 1 year. So what you're going to see is they're going to hit the button twice, not just one time. When you compute this, what you're going to get is 2.25. So I actually just made 25 cents more because they're going to hit the button twice versus once. What if you do it 4 times a year? 4 times a year is 4 quarters in a dollar. It's called quarterly. That means it's every 3 months. So $1 at 100%. I'm going to do it 4 times, so I have to cut that into be 25%. And then the time is 4 times a year for 1 year. That's then going to give me $2.44 with an actual 1 at the end there too. Now let me show you what the other values do. As all we do is change the n to either a 6, which would be every 2 months. If we change it to 12, would be every month. 24 would be twice a month. 36 would be that we're going to do it 3 times a month. And then obviously 365 is they're going to hit the button every day. And here's what we get. You'll see these values. Now what you might notice is from once a year to 2 times a year, we actually made it 25 cents more. And in the next group, it actually went up quite a bit. What it starts to do is it still goes up, but it's kind of slowing down at the rate at which it's going up. It's starting to approach a certain value, and the increase is not as dramatic. So let's even go more extreme. Let's again look back at the same formula. We're putting $1 in at 100% interest. This is for the 365 days, which we already got. So the $2 grows to $2.71. What if you hit it every hour for a year, every minute, every second for a year? If you do that, really notice how much it doesn't change by. Yes, they both go up from here to here. It starts to slow down quite a bit. Well, this individual right here is Leonard Euler. He is the person that discovered that this particular formula had a number sequence. And what it does is it starts to approach a particular final value. It never ends though. It's like pi. It's called the number E. He named it after himself. It's called Euler's number. And what it is, if you look on your calculator, there is a button for the E value. And it is this irrational number that continues to go on and on and on. It gets very close and approaches 2.71828 and so forth. It is a number that is found in nature, And again, we're going to start using it in this section. It's named after Leonard Euler. It's Euler's number.